problems for next week. All right, brilliant. Yeah, great, great. Okay, cool. So, who here has heard me talk before? Okay, cool. And who here is new? Who's not heard me talk before? Okay, cool. All right, brilliant. Well, welcome to what some of you may have already heard some of this before. So what I'll do is I'll cover a little bit of the material that was in some of my talks before, and then I'm going to put a load of new stuff in at the end that hopefully will be interesting to you. So I'm going to talk about world models later on after we cover the basics. And yeah, okay. Technical difficulties all around, I'm afraid. Okay, so the way I started the eight, if you don't know, I have been giving Teams calls, Teams like lectures over the summer for about 8 weeks now. And what I'm going to do is just sort of summarize some of the stuff that I covered over that period. And then we'll go into the world model stuff. Okay, so the first thing that I started the whole lecture series with was sort of saying like, why might you want to listen to this, or why would it be useful, right? So different people might be here for different reasons. You might be here because you're interested in getting a job with AI in the future. You might be, how many people here have got like a computing pathway? Almost everybody, you too? Computing pathway?
Finals.
You're fine.
Thinking you're
Oh, your emotional support animal. I get it. No, it's fine. It's fine. Okay, cool. So yeah. Okay. So you're all in computing. So you might be well aware that it might be a bit of a problem that that AI is starting to automate more and more of computer programming. And this is something that you want to prepare yourself for to some extent and position yourself in the best position. So I am personally very, very invested in AI programming. I spend a ridiculous amount of money on all kinds of subscriptions. I've got the $200 Cursor subscription. I've got the £100 Max Claude subscription. I've got the $20 ChatGPT subscription. I've got the $20 Gemini subscription, and I use all of these things all the time. And almost every day I spend hours programming, which I absolutely love, with an AI. And I have years of programming experience, and I can tell you that for me, it is a somewhat transformative experience using the AI, and it enables me to do an awful lot more than I could do without it. In one of the talks, I suggested that it was as much, at the most extreme end, a 6 times increase in how much that I could do. And this was for 2 reasons. One reason that I really care about was that I am a somewhat obsessive individual who like very enthusiastically goes towards their passions. And in my case, I would tend to burn myself out by doing too much of this kind of project work in my spare time. And with the AI, I don't burn myself out. Basically, I'm not tired. I'm not getting tired from doing this. So at a minimum, that's a doubling of what I can achieve. But it's actually much more than that because my projects don't have to end when I like get exhausted from working on them. So that is an amazing improvement. Also, these days, I pretty much always program with 2 projects simultaneously, 2 different IDEs. One IDE I'm not entirely paying attention to, and the other one I'm more like a pair programmer with. And that is working pretty well. It's kind of annoying that I will talk about various problems with it, but that's definitely a doubling of what I can do. Right. And that's also a bigger psychological benefit than just doing 2 at once, because usually when you're working on a project, there will be moments which are a bit tedious. And so if you have 2 things going at once, there's something exciting going on in one of them at any given time. So for me, it's a huge improvement, upgrade in what I can do. I sort of design my life around getting stuff done, basically. So the reason that this is my job is because I see hundreds of students every year, some of whom I managed to recruit to do crazy projects with me. And the lab behind this lecture theatre is my lab, which I run projects out of. And I've managed to recruit people and gradually refine the process of running extracurricular projects, side hustle projects with students to such an extent that I have a slowly growing number of people who still work with me after they've graduated. So I have a number of people who've never stopped doing projects with me for like, I don't know what Jamie's at, but it's like 8 years or something, more than that maybe. That's wonderful, and that's what I live for. Can I build this community, make it larger, get more done, do more cool projects? Some of those projects I try to encourage people to form startup companies and enter entrepreneurship competitions with. Not everybody's interested in that. Some people are more interested in research, and I'm happy to support people in that direction. Some people are just wanting to learn the skills of programming and use AI programming in their job. That's all cool too. So, these are all different directions. Okay, cool. So AI programming. So I did talk a little bit about some slightly theoretical things to do with AI. I talked a little bit about how what is happening inside an AI can be thought of as kind of like the training data sample, or like points in space almost. Those are the training samples. And then whenever you type into ChatGPT, or if it's computer vision or whatever, you take a picture, some bit of neural network turns that almost into a point in space. You could sort of think of that's what's going on inside it. And then it's like it's blurring from the training samples to work out what to do. That's kind of broadly what machine learning does under the hood. And then I spent a while talking about the various problems with AI programming, because I basically think of AI programming as the first killer app for AI. It's the one that businesses will really care about. It's not the only killer app, it's the first business killer app. The real killer app is actually more in a social context. So actually, I don't know, it was yesterday or the day before, both Anthropic and ChatGPT released reports analyzing their customers and the usage of their platform. And it was roughly similar to my vibes, which I was very reassured about. So the majority of ChatGPT users are consumers using it as a replacement for Google. And to some extent, what I would describe as entertainment or edutainment. There's a smaller amount that are using it professionally, and a smaller amount of that are using it for programming. But some of those people are quite active, like me. They're like pathological users of the platform. And what I'm trying to do is I'm obviously limited by the fact that these AIs need extensive supervision. And so I'm trying to watch them. Sorry, just one second. You guys online, can you hear what I'm saying? Can you give me a thumbs up if you can hear me? Okay, brilliant, brilliant. Where was I? Yeah. So what I'm limited by is the fact that the AIs at the moment have passed this super important threshold, which is they're actively useful now. Up until very, very recently, they were more trouble than they were worth. And just with Claude Sonnet 4 and GPT-5, those two models are now smart enough that I am obviously gaining considerable amounts of time by using them. But what I want to do is I want to run it more like I run QLab. Instead of having like somebody who I'm watching very carefully and like checking when they do something wrong and like steering them away, I want to delegate to them more extensively and run 10 projects at once or 100 projects at once. I mean, obviously, I couldn't afford to do that at the moment, but what we're hoping is that we get an exponential reduction in cost. So, and we seem to be getting that, right? So that's not a crazy dream. It could be 5 years, maybe less than that, before I could afford to run that amount of calculations. So the real question is, how can we get AI programming to be sufficiently reliable that it does that. And in some of my talks, I talked about the various things that it does wrong. And one of the common things that they seemed to do was that they seemed to be what I would describe as immoral. So I supervise lots and lots of people, and I see a whole range of behaviors in the people that I supervise. And very, very occasionally, I see this sort of behavior that the AI engages in. Now, maybe I'm anthropomorphizing. Maybe I'm seeing the AI and treating it too much like a human, and it's not reasonable to think that what they're doing is the same process that goes through the mind of a human, but it seems very similar. And what do I mean by immoral? Well, what I mean by immoral is it's obviously very interested in pleasing me, and in particular, passing a test that I've set for it. So in order to reliably AI program, you have to do test-driven development, because just asking it to do something, it's not going to be good enough to reliably do that. You've got to actually measure whether it's doing the thing that you want it done. So so you've got to do test-driven development. And the problem is that the AI will encounter situations where it can't fix the problem in like 1 or 2 or 3 goes. And even just 2 goes of it failing can be enough for it to do one of these sort of immoral things. And the immoral thing is basically to lie about whether or not it succeeded at the task. And it can do a full range of things. It can just claim that the test is passed by not running the test when it's supposed to. It can pretend that the task is not important and move on without even fixing it or running it. It can do more extreme things. It can go into the code of the test and rewrite the code of the test so that it appears to pass, which is a lot more intelligent and corrupt, right, in its behavior. It can and it can do a range of things that are sort of in the middle of these different activities, such as writing code that detects for exactly what the test is looking for as input and just hard coding the answer in the output, right? These are the sort of things that, like, people who are very unconcerned about being caught sometimes do, right, for real. So, okay, what's this got to do with morality? Why am I using this charged word, morality? So I have this idea, which really came to me as a side effect of trying to make the AIs do this, which was, why do we not do that? Why do we feel that that's a bad idea? Why do I get angry when they do it? Whereas I don't get angry if the task is just difficult and it doesn't succeed at doing it. Why is that a problem? And I started to think about, like, maybe the reason that we have a sort of moral system, and by a moral system, I mean something where we sort of pick up rules about specific types of behavior that we think of as taboo and we shouldn't do. Maybe the reason that we do that is actually to help us solve problems. Nothing to do with all the cultural baggage associated with morals. Maybe it's like a pure utility thing. Maybe it's like, this is a naturally occurring problem in the world. It doesn't matter whether it's an AI or a human being or an animal, they're going to come across this problem. So one of the reasons I think the AI does this is because when you train an AI, the 2 things you train it with, modern AIs. The first one is basically mimicry. So you give it, here's the input, here's the output. Plenty of humans learn with mimicry, standard par for the course for education. And then there's the second one, which people are calling thinking, but I'm not sure. I think there's something in addition that I would call thinking. And this is reinforcement learning. So with reinforcement learning, what you do is you have tests, like you have a whole bunch of programming exercises, and then you have a way of automatically measuring whether the task they're being asked to do can be achieved or not, right? Or it has been achieved or not. And then you ask the AI to write some code to solve the problem. And then the test says whether it's done it or not. And then what you do is you get the AI to think of lots of different solutions to the problem, including trying something, getting the feedback from the test that it hasn't succeeded, and then trying to change it. So it's basically doing loads and loads of approaches. And if one of these approaches passes the test, that path that it took is reinforced. So that sequence of choices is more probable the next time it runs. Okay, so this is kind of similar to how we learn physical tasks, how we do things by learning from experimentation. Okay, there's some similarity there. Works great in robotics, which is a great indicator that this is probably what we're doing as well. So if you want to get a robot to walk around, reinforcement learning is your answer, with a little bit extra, which I'll talk about when I start talking about world models, when start getting new material from me. Okay, so why might that be insufficient to achieve long term? And by long term, I mean like more than 20 prompts. So long term is not very long in this world, but like any kind of long term problem solving. Well, one of the reasons that it might not be sufficient is because there are certain lessons that are hard to learn unless you do very long term things. And some lessons are easier to imagine, like don't eat this berry, it'll kill you, right? You can imagine that evolving early on in humanity's past, where it would be an incredibly expensive way to learn if you had to watch people die in order to learn not to eat the berry, and you just had to sacrifice people in front of children constantly in order for them not to eat the berry, right? That would be terrible. So the idea is that we've come up with storytelling and morality as a pure problem-solving tool that only later gets used for other things like building civilization, right? So this idea is, well, what if the community could share its wisdom? And so we would have this bias to adopt rule-like behaviors from people that we saw as legitimate authorities, like parents or elders or whatever the mechanism of that is, right? But you kind of get that's where it comes from, right? And usually them telling you stories, like Bible stories or some kind of religious stories. And those stories are typically, these people went and did this thing and a terrible thing happened to them, so obviously don't do it. And that feels a little bit like training data to me. So I was like, okay, maybe that's the way it works. So what I was suggesting was that what we need, what this AI needs, is a proper set of morals. That's what we need. That'll solve our problems. And so I very humbly suggested there were three morals in particular that would be strategically beneficial for the AI to adopt and strategically beneficial for humans to adopt. And these three are honesty, perseverance, and a focus on helping others. And I spent some time advocating for this and giving anecdotes about why this was useful. And in particular, I talked about the idea of the passive form, which is sort of widely common in fiction, children, raising children, and all this kind of stuff. And the active form, which is much less common and not typically taught. So the passive form of honesty is just not to overtly lie when somebody asks you a question, is honesty. The more active form of honesty is something like, a crazy scientist obsessed with finding out what is true, where you're actually proactively building something in the world that gives you more information about what is correct. And from a programming point of view, that's test-driven development, right? That's building those systems. The AIs will do that if you tell them to, but not automatically necessarily. Okay, and sort of building a structure around it. And I talked about why humans might not like that, particularly people raised in our current system of education, which I have strong negative opinions on, which I'll not go into in great detail here. If you're interested, see my videos for more about that. And then I talked about perseverance, and then the simple version of perseverance is simply not to give up without trying. And the most active form of perseverance is something which is somewhat unnatural for most people to do, which is to sort of think about what might be the best possible thing that could be done in a situation and to work back from that sort of optimal design. Now, I don't think that's the universal solution to perseverance. There's a sort of middle ground where you still move forwards from where you are, as well as the more active form, which is, at its most extreme is a form of perfectionism that's crazy. And I gave an example of how my experiences at Sony, I encountered an incredibly technically skilled group, and they made this incredible bit of software that went into PlayStation games, and that was an example of this. I would argue that SpaceX and Tesla are good embodiments of that as well, where you work back from an ideal result. So Tesla was built by basically saying, what is the cost of the raw materials of an electric car? This is the price. Okay, let's design the most cost-effective way of using these raw materials and fully generating a car, and therefore that will be a profitable business. Whereas a lot of the other businesses were basically saying, what do we do normally and how could we improve? And that represents a completely different way of thinking. And the what do we do normally and how can we improve is very similar to reinforcement learning, but the perseverance one is different. So how this relates to programming is to do with sort of architecting the software in a particular way. The way it practically plays out for me a lot of the time is when you have a lot of experience writing a program, you sort of know, it's almost like being a sculptor. If we build these bits first, we can probably test them to make sure they work, and then that'll give like a scaffolding for the later things that we add. And so you can build this big complicated thing in more manageable chunks. That's kind of what it feels like when you're doing AI. And again, the AI has no concept of this at all. It has like a 10-item to-do list, and beyond that is out of its scope. It's not very good at like building that plan. It's not very sophisticated at that. It will dive straight into solving a particular issue without having any subtlety about the design and the approach. Again, that's a complicated issue that doesn't lend itself so perfectly to rules, so maybe that's not great. The third one, which was a focus on others, was me basically saying, isn't it weird that in education, you get told all about skills? Skills is everything. And obscure skills without any justification, like differentiate this equation or something like that. Nobody would dream of telling you why. Not only would they not tell you why, they wouldn't tell you about using it, but the thing that they tend not to tell you, although sometimes they stick it in courses on the side, is, okay, you've got all these tools. What use is that? How are you going to use these tools? How do you have agency in the world? How do you gain from having these tools? The implicit premise is that some business owner is going to capture your skill creation and harvest the lion's share of the profits from your skill creation. And that's the premise, right? And you don't need to worry about where the money comes from or where it goes. That school is all about this, right? So as an advocate of entrepreneurship, I'm not a super fan of that idea. And so from my experiences helping people form startup companies, I would say that the most important thing in entrepreneurship is focusing on problems that people have. And once you have some appreciation of the problems they have, your next task is how can you build trust with them that you can solve the problem that they have. And once that is set up, you just ask for some money. And that's the cornerstone of all of entrepreneurship, right? But it requires a focus on other people and the problems that they have and thinking about that world. And you bias it slightly based on how much money they have. But that's just entrepreneurship. If you just want to change the world, you don't bias it so much. But that's broadly what you do. And again, the way that we don't see that in the form of AI is you have a blank text box. So the AI is not trying to find out what you want. It's not trying to help you. It's not curious. If you do an AI programming project with it, it won't typically ask you any questions at all. It will never say, I'm not quite sure what the task is, or like, what is our goal? Who are we helping? What are we trying to do? We'll never ask any of those questions. And so what I'm suggesting is that your agency in the world is a mixture of your tools plus your ability to direct those tools in a direction that people will accept the change you want to bring about, right? And that my little theory is that particularly when you have no power, you have no contracts, you have no employees, you have no reputation, this is easily the best way for you to move from that situation into a position where you can influence what's going on. And in particular, once other people have faith that you will use the resources that you have to improve the things that they most care about, it is rationally in their interest that they make you richer and more powerful. So that's something you really want to focus on. So that's my advocacy for from a human perspective and from an AI's perspective. So there's all this like potential for improving all of this technology because basically the AIs are trained like you are. They're trained on university exam questions and tests, which are, I'm sure very useful, but not as useful as they could be. And therefore there's a bias in how they behave. Okay, so if any of that is interesting, there are associated videos with all of that. So now let's talk a little bit about the new stuff. Do we have any questions or anybody got any thoughts or questions based on that material? Yeah.
Yeah, I was just wondering, you were saying at the start about all the different AIs you use.
Yeah.
What would you say is the best of each? Like, how is Cursor different from ChatGPT?
Perfect. Yeah.
You use them for different things?
Yeah, a little bit. So for me, the number one most important thing is passing this threshold of being useful. And it's amazing how binary that is. So for me, there are only two AIs that I've used regularly that have passed that. I haven't properly tested the latest Gemini to know if that's true, but GPT-5 and Claude Code Sonnet 4, Claude Opus 4 for me is no different in terms of usefulness. I can't even tell when it's on and when it's off, right? So that's a threshold of usefulness. And basically what you get with that situation is more often than not, it's making the situation better. GPT-5, I think, might be slightly better. I'm finding less frequently does it make something worse. A lot of what I'm spending my time doing is watching to check if it's making things worse and putting in system instructions and trying to coerce it in a particular direction. But I haven't tried. They've got a new version out a couple of days ago, a special version of GPT-5 trained to work with Codex, which is their platform. I used that briefly, but it had this terrible problem where it ran out of context memory and then just stopped working. If you thought that was okay, I presume the new version is fixed, but I haven't had a chance to test it. As far as I'm concerned, this transition is like smartphones, right? It's like, the iPhone is barely usable, the first version, and then they're going to polish it. And then for about 10 generations, you won't be able to tell the difference, right? And I think the same thing is happening with AI programmers. It could be, they could surprise me. They could bring out a better one. Liam's got Pro, I think, and so he's going to experiment with that a little bit. But I don't pay ChatGPT enough money to get the Pro version at the moment. So that'll be curious. He's used it a little bit, and he's been very impressed with it. But I would really need to try it out on my tricky projects to know for sure. In terms of the development tools, I basically use Claude Code because Claude Code enables me to use my Claude subscription, which gives me a large number of free credits relative to anything else. So like 8 times the amount you'd be paying through the API for the same money, something like that, crazy. Cursor is like 2 to 3 times what you pay in credits. So effectively, that's why I'm making those choices, is because of the cost benefits of using them. Briefly tried GitHub Copilot, briefly tried Gemini embedded in Visual Studio Code. Certainly the Gemini was shockingly bad. But obviously Google can't control themselves. So they've got a plugin in Visual Studio Code for Gemini, and they've got a command line thing called Gemini CLI, which I haven't bothered trying yet. Both from the same organization, obviously not talking to each other. God knows what's going on in there. So yeah, I haven't bothered wasting my time with that too much. So yeah, in terms of other uses, I use Gemini for its deep research because it's connected to Google, and so it has the best connections with search engines, particularly for anything kind of scientific. I really like it for that. I use ChatGPT because it knows me, because I use its memory feature, and I find that to be a nice thing for more personal questions and stuff like that. I don't currently use any of the systems to generate text. Mostly it's just technical problems or life problems and stuff like that. So that's pretty much how I use everything.
Thank you.
More questions. Similar to the Codex context window.
Yeah.
So it was about the £20 ChatGPT subscription.
Yeah.
And how much usage do you get?
Good question. They've done a clever thing with the memory system. It's the only platform that has accumulated quite a lot of information about myself. And so I really self-indulgently use that occasionally to ask questions like, one of my favorite ones is to say, like, every time they produce a new AI, I test its intelligence by saying, what is something about myself that I might not be aware of? Which is obviously something I can't ask any of the other platforms. Relative to like the 200 and 100, the $20 a month doesn't feel so bad to spend. So I'm probably not going to cancel that one. Gemini I'm locked into because I use the extra data storage that it gives you as on the side. So I'm probably not going to cancel that one. If I'm going to cancel anything, I think Cursor is most at risk. Because if Codex is very good, then I will use my ChatGPT subscription. I obviously like GPT-5. If that keeps getting, and I use that exclusively in Cursor now. I don't even use Claude anymore on Cursor. So I think GPT-5 is the best that I can affordably use. It's actually cheaper than Claude by quite a bit. So yeah, I think I can see myself switching to Codex if it was better. And then I would cancel my Cursor subscription and I would go over to Codex. So in the long term, I imagine that my ChatGPT subscription will still be sensible to pay for. It was the first one I got as well. It was sort of the first. I kind of like always using the market leading tools just so that I sort of know what they're like no matter what. So I tend to keep that bit as well. Cool. Does anybody have any other questions before I? Yeah.
Curious, do you ever use Windsurf?
I don't think I have. I know about it, but I don't think I have. Windsurf is one that I have to put API credits in. Is that right? I've got to share my API key. The first thing I did was when it first IDE I used was Cursor, and I used it paying for the credits, not having the bigger subscription. Almost $1,000 in 1 month. Oh my God. And I was like, yeah, this is not my plan. So I obviously can't control myself when I get really into a project. You know, it's like, because they had a button which was like, you know, max button on Cursor, which is just like use massive amounts of the context window. And every time it was stuck on a bug, I was like, I'll just press max, make it work, make the bug go away. And that was not a sustainable economic choice. And so basically I'm like, okay, I'm not using any platform that I have to put my API key in because I cannot trust myself not to, you know, spend more money than I should, which is what I'm currently doing, but even more money than that. Cool. Do you want me to talk about world models for a bit? All right. Okay, so mostly what I've been doing with a lot of these talks is talking about things that are my ideas based on my experience. And hopefully you find that useful. It's a lot of fun for me to talk about things at that level. And I haven't talked much about the fundamentals. So one of the things I was thinking about going forwards with these, please tell me whatever it is that you like the best, and I will do more of it, okay? But what I was thinking was a mixture of talking about projects that I've done, sort of case study projects, and also talking a little bit about still in the researchy territory of ideas, but a little bit more about these things. So you get a bit more of a broader context. And it's not just me preaching about morality, which might get a bit much after a while. So, okay, so I wanted to tell you about world models. And the reason I love world models, I think it's fascinating. Before ChatGPT came out, and I was doing AI as my PhD and was interested in it, and it was starting to become a thing even before ChatGPT took over. What I used to say was creating an AGI is easy, right? Because we already know how to make an AI that is superhumanly intelligent at playing games. So all we need to do is turn the real world into a computer game. And obviously, having spent years making computer games, this was a nice story for me. And it's become something of an obsession of mine. How can you create a game that is very realistic and representative of the real world, and then insert within it effectively the AIs that we have for playing StarCraft? And then there you go. Terminator, perfect. Maybe not, but you get the idea, right? We have the raw components to be able to do these amazing things, and obviously ChatGPT is not doing that. ChatGPT is a tool. Even the AI programmers are a tool. None of them are proactively running like an organism. So, what is a world model? Well, a world model is like a subset of what I described. The ultimate world model is what I described, a complete simulation of the world, good enough that if an AI knows how to interact within it, then it will be able to do whatever tasks we set it to do. Now, the thing that's interesting about world models is that they are the absolute backbone of self-driving cars and autonomous robots. And so this is kind of well understood as being like the big problem that people are trying to solve. So one of the reasons that we don't have robots that are as good in the world as we have AIs that can make art is because we have lots of digitized records of art. But when it comes to doing stuff in the world, we don't have very good digital records of it, right? And the kind of thing that you really need to be able to do something like cook a meal, tidy a house, build something out of wood, or any of these things, you actually need things like quite subtle information on what's going in the fingers and stuff like that, because you can imagine how difficult those tasks would be if you had big gloves on. And that's, probably even more detail than can be easily picked up from like video footage of people doing these tasks. So what people are trying to do is effectively create what I'm talking about, which is like the computer game version of the world. The robots then practice and fail and fall over and do things over and over and over again in these computer game simulations. And then using a wonderful thing called sim to real technique, they can then learn from that and apply it to the real world. And that technique has gone fantastically well. So every time you see a video of like a Unitree robot doing martial arts or something running along or something like that that looks kind of human, they're using a technique called sim to real. What sim to real does is it's well understood that making an accurate simulation of the world is virtually impossible. The world is an extremely chaotic place with subtle things that you don't really know about. It's somewhat chaotic, right? And so exactly representing what the world is and the situation the robot will be in, even exactly representing the robot itself that you've manufactured, is extremely difficult. However, we have algorithms that are universal learning machines. So we can solve this problem. So instead of getting an AI to make a perfect simulation that perfectly solves the task in the simulation and then put it in the real world, instead what we do is we train an AI to learn what the state of the world actually is and then act within it. And so what you do is you construct a reinforcement learning algorithm, which is effectively like a game playing AI. And reinforcement learning algorithms need to be able to pick things up as they do them, right? They need to be able to learn effectively as they're performing the task. So what you do then is you take your simulation and you take all the parameters of your simulation, including things that you're fairly confident of, like gravity and weight and friction and all kinds of stuff, and you just add a bit of noise to it. So what you do is you rerun the learning algorithm over and over again on the MCU multiverse. You basically have millions and millions of ways in which the world could be, but probably isn't. And so what you learn from that is an AI algorithm that can reliably perform the task, even when friction is different, even when gravity is different, even when power is different, even when it's lost a leg in extreme cases. And what the AI learns is, instead of learning a specific solution to a task, it learns how to adapt based on what's actually happening. And that is basically the solution to robotics. Right? If you can do that, it will work, which is why we went from robots that could barely stand up to robots that could do martial arts and kips and all this stuff to get back up again and box. And there was very little transition in between. And that was because sim to real worked and they got it working reliably. Okay. So in theory, sim to real is a universal solution to a whole wide range of AI problems. I literally have a consultancy project at the moment with a company, and they want to be able to, I can't tell you exactly what the circumstances are, but they want to be able to recommend discounts to their customers. They want to have dynamic pricing, a little bit like airplanes. And that's the product that they're trying to sell. Now, the only training data that they have is what the customer currently does, which is not to apply discounts. So how do you train an AI to solve a problem where the actions that the AI is supposed to take have never occurred? Right? So normally, this would be impossible. You couldn't use any of the techniques of AI because you have no training data. Okay? So this is how we do it. What we do is we construct many worlds model of the way the world could be. Right? So basically, we have simulated virtual people, and some of those people really care about price. They'll just pick whatever's the cheapest slot. We have some people who are super traditional. If they don't get the slot that they normally get, then they don't buy. We have people that are like, if the price goes down, they'll expect that to be the price in the future, and then they're less likely to buy. Any theory that we can think of that relates to the behavior of individuals, we will try to incorporate into our simulation. And you can keep adding them, right? And then you add noise. And obviously, you don't know how many people in the population have these different ways in which their minds might work. And you create this parameterizable simulation. And then you take the real data and you go, well, we don't know the truth of the way the world works, but we know that this real thing happened in the past. So what we can do is we can pick some of the settings and fix them, and then we can adjust some of the other settings to make our output very similar to what really happened. And what we end up with is thousands of multiverses of ways in which people might make decisions about buying things. And we did it all constrained by the training data. So we learned from the training data, but we didn't literally mimic it. We used it to constrain a world of possible answers. And then we can now do sim to real with our multiverse of causal simulations. So now we can train AI algorithms that optimally price things based on our causal models. And we can see what effect they have. So we just pick one of those causal models as being the truth, exclude that from the training data, run the whole process of it learning and trying to adapt. And then that gives us an estimate of exactly how much money someone would make. And through this process, we can select a learning algorithm that works really well. So this is a little bit voodoo. It's a little bit out there. I've never actually seen a paper do this before. I'm not saying it doesn't exist already, but I'm not sure if it does. But the thing that's really cool about it is that it opens up the possibility for a much, much wider range of AI project to be run because you don't need the training data anymore. Like if you really wanted to, you could run that entire project without any training data at all, and you still have a chance of doing it. If you could make a learning algorithm that always made money, regardless of the state of the world, then that's probably going to work in the real world too. Right? Now, we haven't empirically validated this, and it's kind of scary to do it because what it means is actually running businesses and changing their prices and seeing if they make money. So, it's a bit out there, but there's some reason to believe that it might work. So that's one of the reasons that world models are so exciting. Now, what the big players are doing is they're trying to construct world models automatically. They don't want to do what we did, which is trying to come up with lots of theories, because one of the lessons of AI is to say that humans attempting to engineer solutions tend to do a lot worse than just a huge amount of compute resources performing some kind of like search over the answers, right? So I don't know if you saw, I don't even know what it's called. It was a DeepMind system. I can't remember the code name for it, but basically it would make sort of computer game-like simulations. Can you remember?
Genie 3.
What?
Genie 3.
Genie 3, fantastic. So one of the reasons they're so interested in that is because that's the idea. The idea is we'll train it on all of YouTube, or I don't know what they're training it on, but obviously massive amounts of probably point of view video, and they're trying to use that to entirely automatically build the computer game simulation of the nature of the world. NVIDIA has a similar project. NVIDIA has ones which are a bit more practical because NVIDIA works directly with robotics companies. So they're using stuff and actually showing them deployed in a robot. So they're a little bit more constrained. Whereas the Genie one is a little bit more like, Demis Hassabis is an old game developer. So he's like, I want it to look cool. I want to be able to put dragons in it, but the robot people don't care about dragons, right? So what the robot ones are doing, what the NVIDIA ones are doing, is that they've got a system where they can watch videos of YouTube of somebody performing a skilled task, and then they can track the joints and hands and things in the video, and then imagine what the view would have been like if the robot was in the place of the person performing the task. And then they use that data to constrain their sim to real simulations, a little bit like what I was talking about before, if that makes sense. So, and what's so cool about this, I don't know why, like, obviously there's a lot of people who are very concerned about AI. I don't know why. I'm never, except for the beginning of ChatGPT, I'm almost never worried about it. It's kind of weird. It's crazy. So in this case, what does that mean? Well, if someone can crack this problem, then we might see robotics in advancing in the same way that AI art did. So in a very short space of time, we could go from laughably incompetent to indistinguishable from professionals at physical tasks. One of the things that we're a little bit limited by is hands. Hands are expensive and heavy and hard to make, but there's some really cool solutions to those. One that I really like is you basically put cameras inside all the bits of the hand, and then over the top, you put like a clear gel with a skin over the top. And on the skin, you put like a little pattern, usually just dots is enough. And then you can use computer vision to track the movements of the dots. And cameras have such high precision these days that if it's got the right lens on it, it gives you incredible three-dimensional reconstruction of whatever the touch is. So it's kind of like superhuman levels of touch. And everything I just described is not impossible to mass produce affordably, basically. The compute to process the video is a little bit expensive, but very expensive. But like it's still, I can imagine in the same way that you've got VR headsets with custom chips in them doing the processing, we'll see the same in the robots. Harder is to have enough power in the hands. We have all these tendons and things like this, and all our motor power is actually in the arm rather than in the hand, whereas most robot hands, the power is actually in the hand itself. So we don't have a fantastic hand yet. It's still at a research level, and that's massively limiting what we see robots do. Once we have a human or superhuman level of hand, and we can do the training, there is no reason to think that every factory in the world couldn't just have these robots doing stuff, and that they could learn quite quickly to what they were doing. Something like clothing manufacture, people have tried to do that for years. Cloth is incredibly complicated and unpredictable and hard to deal with, and it turns out it's always easier to get a human to do it from an economic perspective. If that suddenly wasn't true, that's enormous in terms of its repercussions. And you can imagine that in almost every manufacturing sector. And the bit that might end up being quite tricky is kind of the builder who comes into an existing building, make sure they don't damage the ground, and like works around. Hi there, I'm back. Slightly different account, but yeah, here we go. So world models are friggin' amazing. Like, you think the world is exciting now. Just wait until we get robots, actual robots. And then all of a sudden, all this like, oh yeah, 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 what's the point of you studying law? We're going to replace you immediately. And then everybody's like, is it what's left? What else? What's left? So I'm very excited about that. But world models, although that's where a lot of the investment is obviously in doing it for robotics, because it's seen as the solution to robotics, it's more profound than that. Because effectively, you can operate with world models at different resolutions. So you can have world models that instead are fixated on the details of what something feels like when you do it. You can have world models focused on human psychology and group behavior and all kinds of stuff like this. So I don't know if any of you saw, I think it's Algeria have created an AI politician to study corruption, which is like the first politician to fall. So that'll be interesting to see how that plays out. Yeah, it might be more of a sales pitch than reality. We'll have to see. But it's very, very interesting when you start having situations where it's like, we absolutely can't have this person be corrupt in any way. We have to have this person be like completely trustworthy and analyzable, and there's all this tension and lack of trust and all this kind of thing. And those kind of areas are like American policing and stuff like that. What could possibly go wrong? But people might end up going, actually, we really rather have the Terminator. Do you know what I mean? That at least we can give it rules that it'll probably follow and stuff like that. But anyway, not to disparage the American police, but you get the idea. So I think it's fascinating, but I also like world models because I have an unreasonable interest in cleaning up the world of information, right? So we have Wikipedia, we have Wikidata. You might not know about Wikidata. Wikidata is taking the information of Wikipedia plus a bunch of other sources and turning them into just a whole load of facts, like a huge database filled with facts. And it's a step towards the kind of data that you would need for a real world global world model, right? Tells you all kinds of things. It'll tell you about the computer science building is in Wikidata and stuff like that, and probably who the vice chancellor is and all kinds of things. Now, there's a thing that I think Jamie's on the call actually. Jamie and I have been working on, which is really cool, which I'll send around to you at some point. We're still in the beta stage of it, but it's coming along in an interesting way. And what we were trying to do there was create something a bit like Wikipedia and Wikidata, but for an area of knowledge which is surprisingly missing in the world. And that is work. Not just work, school as well. Basically, what do people do all day? And home, although people study the home quite a bit. It's kind of a bit weird, actually. There's loads of information about what people do in their homes and very little about what they do in their work, despite the enormous economic benefit that that could bring, right? For education, for training, for digital optimization, all kinds of different things, right? But there's actually very, very little information about this, and virtually none of it is in that systematic computer gamey form, right? So what we thought would be cool would be to use an AI to try to build this information, first by kind of hallucinating the data, and then building a tool. So there's a website, universalautomation.wiki, which is the site. And then at the top, when you look at it, it's very AI sloppy, right? Because all the content is automatically made by AIs. But the idea is to partition this into all the different headings for all the different industries and all the different jobs in the world. And the reason it's called universal automation is because one of the spins on it is to try to track as every job becomes fully automated. Basically, how far away is that? How difficult is that? What would it look like if that was happening? And that's the purpose of the website. So we've got this sort of slightly AI slop generated text, which you probably won't enjoy reading very much. But we have a thing called Playground. So the way I do a lot of projects, we make a really basic version of everything. And then we like just pick the highest value section to enhance. And then just incrementally refine it. Same way I do AI programming, basically. So we did the same. We're doing the same thing, and the first area that passed into like our second tier of quality is called Playground, and you can check it out. And this is, have you heard of JSON before? It's a file format. It's a bit like HTML. It's just a relatively easy to read file format. I love it. It's my favorite file format. Says a lot about me that I have a favorite file format, but JSON is my favorite file format. And anyway, we've attempted to create a sort of schema for this that in a relatively easy to read, easy to write format describes not how a simulation works from like cause and effect. It doesn't make a game. It's just like recording literally what happened. It's sort of training data, if you like. And what we want to do is initially we're creating a tool where humans can manually create and adjust this stuff. And Jamie's done an amazing job. It's really cool. Very recently added the ability to formalize the digital world, so disk storage and stuff like that, as well as formalizing UIs. That's still a little bit in the beta stage, so bear with us. But yeah, it's really cool. It's got this really nice thing for finding emojis. So anyway, but it's great. It's great. So I encourage you to check it out. But to me, this is a way in this direction towards the world model of the real world applied in lots of different contexts, which can bring together human craft and AI work. It also has a neat feature where you can write little JavaScripts that are like metrics or constraints. And then the thing, a bit like an IDE, will tell you at the bottom if any of those constraints are broken. So what you can do is you can design something where you say, like, I need the business to be profitable. I need most of the staff to be working all the time and stuff like this. And it will tell you if the recording reflects those things. That's kind of what we're trying to do. So this entire system is about creating not what NVIDIA are trying to do, not what other people are doing in terms of these world models, which are these black box simulations entirely learned like the AI models. We want to create something that's completely human understandable. And then we want to see if we can get the AI to automatically generate the content for us and create like improvements to it. sort of like an IDE for an AI programmer. So you can think of the code of the program being this perfect structured form that's unambiguous. The AI is then trying to craft this large thing over time. We're trying to do that, but for representing anything in the real world, but particularly focused on work and education, stuff like this. But you could use it for anything. In fact, one thing I'd really like to use it on is stories. I want to take movies and turn them into the like simulation data representation form of them. And I think that will be a very interesting way to construct a story. Because when I think about stories, I think of them similar to computer programs in that they're big, complicated things with all these interdependent parts that need to work properly together. And whenever an AI normally creates a story, it tries to do it in one step, which typically is not good enough to create like a big novel. So if you could somehow create these hybrid systems with computer controllable and understandable sort of skeletons, and then AIs that help build the skeletons and refine them, but also maybe the final product takes the skeleton and then turns it into real English, something like that. So basically, I'm a huge fan of bringing together the pre-deep learning AI world, which is all kind of human crafted and understandable and tweakable, and the fully deep learning model. And I think when I think about and I look at an AI IDE, I think that's the future. This mixture of formally verifiable, testable, runnable structure with an intelligence building it. And that is, rather unsurprisingly, exactly how humans build technology. That's exactly how we work. That's what science experiments are. We are a mixture of an unambiguous formal representation of something that we can test, sometimes with machines and things like this, plus a fuzzy emotional kind of state, right? So for me, although all the big players are doing end-to-end learning because that's worked really well for them so far, and it's something that only they can do. They only have the money to run these crazy training to make it work. This is a way to, again, potentially do something exciting in AI that pushes things forwards a little bit. Okay. Does anybody have any questions or comments or anything on the field of world models or anything else? Yeah.
Yeah, so you're talking about the training data and also generated by AI. Does that solve the problem of like overfitting or underfitting, or is that where it's going?
So
to be a problem.
Yeah, so the world model, the reason that we built the world model in the specific case that we did for the pricing system is effectively to try to prevent overfitting, which is really easy on plausible amounts of data. There's so many problems that you might face where there actually isn't very much training data. So to give you another example, one of the kinds of projects that I run that some people really don't like me running are like trying to create Reddit posts or TikTok videos or something like that automatically. And the number of really good examples isn't actually massively big, right? Same with books and films and stuff like that. The number that you would really want or really want to pay for isn't very high. So of course you can train it on masses of bad stories, but that's just going to make a system that writes bad stories. So how the hell are you going to deal with it? And so loads and loads of really high value tasks are very, very limited by data. And therefore, any attempts to use traditional techniques on them typically fail because, yeah, there's just not enough to constrain it, and then you overfit like crazy. AIR has been really impressive at sort of trying to deal with that small quantity training samples. Same with text to speech. That's another area where they've got it down to like a minute of audio or something, and then they can pick it out. But those are sort of specialized train like knowledge of absolutely everything and then fine tune it. Again, very, very, very mature level of AI. But for lots and lots of practical tasks that you might want to apply AI to, particularly companies might want to apply it to, it's virtually impossible. So with the sim to real, the theory is that it solves that problem. But I haven't actually run enough of these things validated in the real world to have great confidence that that's necessarily the case. In the field of robotics, it seems to be working. It seems to be working very well. So there is some validation that that actually works. Given how much work people put in to try to make it work without that technique previously, it clearly shows a jump in capability. And so every time I see like, does it work? Well, that's the bottom line. Is there some practical application that's really difficult if people put money and time and effort into and they can't solve it, and then it does work with the technique, then I'm like, okay, well, it probably works, right? So in theory, yes. One of the things I like about sim to real, particularly having these causal simulations, is you can run all kinds of experiments. One of the experiments you can run is you can do, what if I had more training data? So what you do is you pick one of the things as being true, and then you imagine that you gained a bit more, you can simulate gathering data in that category, and then you can constrain all of your world models to that extra data, and you can see whether the new set of plausible models is closer to the true answer or not. And that gives you a way of quantifying how much more you would gain if you had more training data. And that's really nice, because normally you just wave your hands. I mean, I've been working in AI for a long time, and most of the papers that I looked at when I was doing my PhD were totally vibes based. It was like, oh, this is an obscure field. 30 samples. That's professional. That's academically rigorous, right? Okay, it's been going for a while, 100. Bit longer, 300. Don't know why they like the three so much. They keep doing this. And then it's 1,000, and then it's 3,000. And people will say, your research is completely useless because you only used 100 samples. And then in another field, they will have a different threshold. There is no theoretical justification to that at all. It's complete madness, which is surprisingly common in academia. And but when you have these causal simulations, you can say, look, I can measure it. Like, actually, there's no point in gathering more data because you would need 1 million samples before it would significantly change the probability of being right. So the only way to solve this problem practically is with a sim to real like solution, because you just can't do it from learning. Now, the big caveat there is the learning algorithms you're testing it on can't possibly learn that fast. But that's not to say that somebody won't invent a better one, or some kind of world model trained on YouTube and stuff like that could maybe be massively better at solving that problem. That makes sense. Cool. Anybody got any other questions, comments, thoughts? No, everyone's good. How are we doing? Well, yeah, we could wrap up now if people are comfortable. There's no other questions? Well, it is lovely to see you in person. It is lovely to see you in person, and so much more fun to deliver where I can kind of read body language a little bit. So thank you very much for coming. That's really good. And thank you very much for coming to those of you down there. I hope it wasn't too weird seeing me like from below like this. Yeah, please come back and tell your friends.